which simply means that if you are to integrate this, that is getting it back to the original question, it will just be something like that, isn't it? It will just get back to something like that. So that's the message. So now, when you're differentiating by substitution in general, you look at the function, let's say f of x that you're given, and then you have to split it, all right, into the GU function and find a du over the x. So separate the function. I will explain that. So find a GU function, meaning differentiate the function with respect to u, and then find the du over the x, meaning the u function differentiated with respect to x. Du dx it simply means the u function with respect to x. So then the f of x function shall be the GU function multiplied by du over the x. And that is how it will come out. So that when you differentiate this, when you integrate this, you can still get back to GU again, the GU function plus c, the constant. Let's check if there is an example. Examples always make it better. What you're trying to say is when you have a function like this, right, it should be broken down. The substitution by parts simply means you will have the inner function like this one. You get this inner function, okay? This function shall be, you will call it the GU function. Like you put a U, it's U substitution, this is the U, but the inner function is expressed by putting U. So your function will be more like y, the integral, y 5 multiplied by U, you're following, right? To the power 5. You get what we mean? So this is the U function, okay? So the inner function inside is called the U function multiplied by what? Okay, the derivative of the u function by du over dx, which means this u function which is inside, differentiate it with respect to x, it will give you that. I'll repeat that so that you pick it properly. We are saying that number one, the inner function that is inside parentheses when you're using u substitution shall be your what? Your GU function. Okay. Then you differentiate that function with respect to what? To x. This is what that means. So when you are doing those derivations, then you will see that the function will just get back to the way how it is. Yeah, it will boil down to GU like this, GU plus C. So so what that means is that if we are to have a function like this, let me say, let me have the function. This is our function. Our function is y is equal to 5, open the brackets, x squared minus 4x plus 7 raised to the degree 4 multiplied by what? 2x minus 4, right? What this means is that this function, the function itself had to be, because it's a derivative, this one. So this inner function is the one that had been differentiated to give you this GU function. That's what that means. So you have this, the du over the x function, the derivative of this function with respect to x. The u function, this u function here with respect to x, differentiated giving you that. Okay.
Kindly repeat, Samuel.
I should repeat. So I am saying that we do know that whenever you differentiate the GU function, like you have a function like this, y is equal to, let's say, 5, open the bracket, x squared minus 4x plus 7 to the power 4 multiplied by x, 2x minus 4. We are integrating. We are not differentiating. Since we are integrating, we do know very well that this function here, it was the du of what? Dx, meaning it was basically the derivative. You're following, eh?
Yes.
It was a derivative of the inner function that you are seeing here. You get? So since it was just a derivative, we'll leave the inner function without deriving it. And we know that this 5 here that was put down, it was a power. Okay, you have to drop the power using chain rule. So we are just doing a reverse. This power 5, bring it back where it was, and then we are fine. We are getting back where we came from. I said integration is about going back to where you came from, right? Then differentiating is reducing the function. Okay? So similarly, if you could have another function, let's say you have y is equal to, let's say 3, plus x squared minus 4 x. Then you have what else? This to the power 2, obvious. Exchange rate has reduced, the function has reduced. And the derivative of that is 2x minus 4, right? What that means is that this function, the inner function, has been differentiated, right? It has been differentiated. So just leave it the way how it is. And we just get this 3 back to be the power here, because we knew that for this 3 to come down here, it was a power, it was dropped. You're following, right? Yes. It was a power dropped and it reduced by 1 to become 2. So it will be just x squared minus 4x raised to the power 3. Yeah. This is the original function plus c, the constant. If you are to differentiate this now using chain rule, it will be drop 3, maintain the inner function 4x like this to the power 2 now, and then you have the derivative of this, which will be 2x minus 4. You've gotten what I mean? We have now differentiated it. It gets back to this. But we are talking about getting it back to where it came from, which is this side. That's integration. You got it? Hello? Hello? Hello?
Hello?
Hi,
Hello?
we lost connection.
Hello?
Hi, I'm here.
Sorry, I received another phone call.
Oh, okay. But you got what I said?
Yes. I think I did. Yeah.
Yeah. So basically, it's just that difference. Now, integration by substitution is actually a very useful method to solve integral calculus, right? Yeah. It's a very useful method, because when you get the integration by substitution, when you're using U substitution, it's just basically doing the reverse of chain rule. It's just the reverse of chain rule, right? Now, there is also what we call integration by parts. When you talk about integration by parts, this is where you first start with the product rule, yeah? Integration by parts starts with the product rule. You remember the product rule goes with the u v prime plus v u prime, right? What is v prime? V prime simply means the derivative of the v function with respect to x, which is dv dx. This is v prime, and u prime is what? du over dx, isn't it? That's the same stuff. This is the product rule that we communicated to ourselves. So we are saying that if you do that, then when you're using by parts, you have to integrate both sides of the equation. So you have this particular function. This is how it will sit, right? This is the formula. The formula will be uv, the integral of uv, equal to, these are two different functions multiplying, equal to what? The integral of u dv, you're following, right? Plus the integral of v du. That is the integration by parts. This is the formula. Simple. So in short, when you get you have two functions integrating together, just like the product rule, the way how it is. So now there are two functions multiplying together, right? So what you're going to be doing is you're going to separate these functions. You name one u, the other one v. You get what I mean? Eh?
Yes.
One function u, then the other one v. Okay. Then we know that when the v function is differentiated, what do you get? You find the dv, right? And when the u function is differentiated, you find what? Du. So in short, find the u, name one function u, the other one v, then differentiate. Find the du and what? Dv. Facile. You've gotten that one, right?
Yes, name one function u and the other
one v.
And differentiate.
Differentiate.
Which one do I differentiate? The
okay. All of them.
Okay.
Then you integrate both sides. It's quite easy. Yeah, it is sat down here. This is what it's udv, uv, like they've just said. The final is the integral of u dv equal to uv minus the integral of v du. That's. I think there should be a good example that we should actually use so that you're fine. Let's check if we could have an example. Yeah, there is one. Have you seen the function that we have now? Quite interesting function, right? It's x exponential to the power x, then dx. Now, this function, if you check, there are two different functions here. Let me write something like Liate. These are different forms of functions, if you remember. This one is linear function, L for linear. Just linear function or linear linear functions that are linear. Okay. These are inverse functions, the inverted functions. Then these are algebraic. These are algebraic functions. Then these are trigonometric functions. Okay. And these are exponential function. Now, what's the use of this? This is used to guide you on which one to name what? U. All right? U. So what do you have here? Here you have x. X is an algebraic function, isn't it? Yes, it's just algebra. Then E is exponential function. If you check, X comes, algebra comes earlier than exponential. So which means your U shall be X. In this case, you say U is equal to X. That is what will guide you which one to name U. This form. Then which means dv will be the other one. Right? So if you find this, then it's very easy. Let's go ahead. Our x is which one? Which one is our x? Our u is this one. Then the other one will be dv. So what do we need? We already have u, right?
Yes.
Then we need du. Du is the derivative of this, isn't it? The derivative of this. So the derivative of u is equal to what? The derivative of x is what? Is it not 1?
It's 1, yes.
Yes, it's 1. But this one is dv. You know what dv means? dv simply means it's already a derivative, right? So we need it to go back to v. Okay, we need v. Yes. So how do you get a derivative back to v? We integrate. You got what I mean? Eh? If you differentiate the v function, you find dv. Now, if you want to go back again from dv back to v, you integrate. So you have to integrate the v function. So how do we integrate this exponential function? You remember those rules that the exponential function rules on integral, you haven't just followed. We said that if you integrate the function like this, the integral of this is just the same. If you're integrating e to the power ex, the formula that we said, you said this is equal to the same ex. Yes. You remember the rules of integration of logarithmic function and exponential function? It was the same day when I spoke about it. Please visit them. Yeah. So after we have integrated that, we have our v. So we have all the parts that we need, isn't it? We have u, we have du, we have dv, and we have v. So just to replace here, u dv is equal to, right, the right-hand side. What is our u? Put u. V, let's put our v, minus. V, we put v. D, du, what is our du? What is our du?
dx. Du.
Yes. Du is equal to dx.
Dx, yes.
Yes. It's dx. Du simply means, look, you are differentiating the u function, which should be equal to what? Du over what?
Dx.
Over dx. Then dx. So now, since the du over dx is 1 dx, then we'll just put 1 here. So it's b times 1 here dx. You get what that means? Du dx. So is that easy? Ma?
I need to go through.
Maning say. You'll be fine.
Yeah.
So, in other words, when you differentiate this, you find that du over dx is 1. This side is 1. Then you make the subject of the formula du. You've seen, eh? Du over dx is still du. Dx equals to what? Du. Right? Now, u function is 1. Then you just have du equal to dx. So, in other words. Right?
Yes, sir.
When you do that, then it's easy to simplify from here. You go ahead and have x e to the power x minus e. What is the integral of ex to the power x? Can I just integrate in this one? Okay? This one. What is the integral of the a? It will still be the same thing, isn't it? That's what we say. So that's that. Quasila, then you plus c the constant. You get what that means?
Yeah.
That's the interest. So now the issue is, if the examiner wanted to become very interesting, you'd have something again here. What if this was not 1 here? It was something like, at this stage, it was x e to the power x minus e, you know, the integral of ex to the power 2, or 2 dx then. What that would have meant, you could have factorized the 2. It would have been x, you know, minus e, Factorize 2, then integrate what? This. That's how you work with constant sign. Dx. So it would have been x.
Hello?
Hello.
Okay, I stopped listening.
Oh, you got it now, eh?
I get it, but I think I need to go through.
You have to factorize like this constant, whether it's a fraction or it's a whole number, factorize it.
Yes.
If this function here were maybe again 2 different functions, maybe it gave you something like this at this stage. Minus the integral of x, you know, the integral of x e to the power x, then dx. You know that this again would have required you use by parts again on the other side, because these are different functions now. Okay, so you needed again to name another function. Put this aside, first save it one side, you would join it, you solve this, you continue solving this right inside. Again, you name one u, the other one again dv. Again, you solve, then you join with this. And when you're done solving right side, join them, they would come to plus c the constant. That is the integration by parts. Okay.